Okay, 1.4 part 2, isolating variables. So let's turn to that section. And we've got this page here. Now, you got to be careful on this particular section because of the fact that we don't know what variable we're supposed to solve for, and until we read what they tell us. We just don't assume it's for y on the particular equation. For example, number one, where it just so happens that we are asking to solve for y. So that means what we have to do is get y by itself. Or the first thing we do is get the y term by itself. And with this particular problem, it's the y is isolated. It doesn't have a coefficient. So this is pretty much a one-step equation or problem because to get the y by itself, we have to undo the 7x. And if it helps, put your dotted line there, just like previous sections. We're going to minus what we don't want here, minus the 7x, because we're undoing the addition of 7x. And we have to minus 7x on this side. So after we minus these, now we don't need to put a 0 there because I'm going to bring down this term, positive y, or y, equals. Now, do not combine these like unlike terms, okay? This is a constant term, and this is a variable term because it has an x there. Also, when you go to put this bring these down because you can't combine them, they're unlike terms, put it in standard order. Okay? The variable term comes first, and then I'm going to bring down my positive 8, and there's my answer. It says solve for y, that means get y by itself on one side of the equation, everything else on the other side. That's it, we're done. All right, problem number 2. This time, we're supposed to solve for t. So t is part of this term. When I say this term, it's one term because this is multiplication between all the variables. So what's that going to tell me is, hey, since this is all multiplication, I need to undo it, and we undo it by division, and divide by what I don't want. In this case, I don't want the p, and I don't want the r. And don't forget, whatever I do to one side, I have to do the other. So I'm going to take this L and divide it by PR. So on the right side, the P's cancel, the R's cancel. I get my T by itself, down my equal sign. And here's what I have left over. I don't care what it looks like. I want to solve for T, or have T on one side of the equation by itself. Isolate this T. Here's what I have on the left-hand side. I have that L divided by the P times R. There's my answer. Okay, number 3. This time they want me to solve for x. So first thing I want to do, this time the x isn't by itself, it's with a coefficient. I want to get the term by itself first, and then get the x by itself. So I'm going to undo the subtraction of 9y. So I'm going to add 9y to both sides. And I get, let's see, I got a 0 here, but that's okay. I'm bringing this down. Don't need to put the 0 there. I have 11x, and that equals, now I'm going to put the 9y first. Again, it's just standard form to always have your variable term first, then a plus -4 or -4, and then I still need to get the x by itself, so I have to divide it by the coefficient, 11, divide everything by the coefficient, 11. These cancel, and I get x equals 9y minus 4, all divided by 11. Again, I don't care how ugly this side looks, as long as I have that x isolated. Number 4 says solve for y. So I'm going to, oh, look at that. I have it in both terms. So because I have it in both terms, and there's two terms here, uh, if I tried to bring this term over here, then I got y's on both sides. It's best to leave the y's on one side of the equation. However, I need to make two terms into one term here. And the way I can do that is I can do what we call, well, it's not a mathematical term, but I'm going to undistribute the y. In other words, instead of distributing y over parentheses, I'm going to take out a y. And what I'm really doing is I'm taking that xy, I'm dividing it by y because I'm undoing the multiplication here. So these cancel, and I'm left with the x minus sign, and then I'm going to take this y divided by that y, and anything over itself is 1. Now this just became one term. I made it a term, one term. So now I have division between, oh, I'm sorry, I have multiplication between the y and this quantity. It all became one term because of those parentheses. I can now undo the multiplication by dividing by x minus 1. So that these cancel, numerator and denominator, and I'm left with y equals 10 over x minus 1. If you want, you can leave the parentheses there. I like what's called undistributing. Not really, there's no mathematical term for it, but that's kind of what we call it. All right, number 5. I have AB equals 5A plus 4. This time I'm going to solve for capital A, which means just like in number 4, where we had two terms with y, here we have two terms with A. So the first thing I want to do is get those same terms on the same side of the equation. So I'm going to subtract 5A from both sides. So I get, now these still are not like terms. Keep them separate. AB minus 5A. At least I have the capital A on the same side of the equation. Excuse me. And now I'm going to undistribute the capital A. So AB divided by A is B. 5A divided by A is 5. Undo the multiplication between the A and the quantity B minus 5. These cancel. My answer is A equals this mess over here. 4 divided by B minus 5. And again, if you want to put parentheses there, you can. And number 6, they want us to solve for B. So B's way over here. So first thing I need to do is bust up this fraction. So I'm going to multiply both sides by this 5. I'll be able to get into just the numerator then. So I'm going to get rid of the denominator, multiply both sides by 5. I get B plus 3A over 1, or just B plus 3A. 4 times 5 is 20. See, I want to get B, so I want to get B by itself. So I'm going to subtract 3A from both sides. So I have B equals, again, I like putting my variable term first, standard form, negative 3A plus 20. Do not combine them. They're not like terms. And the reason why we sometimes like to change and solve for different variables is because of what we get into real life problems with. For instance, given the volume of a given pyramid is found by this formula, V equals 1/3 times length times width times height. Now, sometimes we don't really care. We're really interested in how high something might be. So what we'd like to do is rewrite the formula finding the height. So in other words here, they want us to solve for h. Okay, so we got this formula. We want h on one side. So what we're going to do, well, let's get rid of the fraction. You want, we can get rid of the fraction first. Multiply both sides by 3, or 3 over 1, the reciprocal. And I get 3v equals, these cancel, I get L times W times H. Now I want to get rid, there's multiplication between all these. I want the H by itself, so I'm going to divide by L and W. So I end up with 3V divided by LW. That equals, these cancel, my H. I gotta move this down here. I have to adjust my camera. Okay, then in B, it says, find the height of the pyramid when the volume is 240. So there's my V. That's my V. The length is 10 centimeters. So there's my L. And the width is 9. So here's my W, it's 9. Okay, so my volume let's see, my volume here is V. So I have 3 times V, my volume, 240. Substituting in 240 for the V, divided by my length. See, my length is 10. So I have 10 times my W, which is 9. W is 9. And that's going to equal my height, which is what they're asking for. I plug all that into my handy-dandy calculator. Let's see, 3 times 240. Now I'm going to hit the enter button because I don't want my pen disc to mess things up. Divided by 10 times 9 is 90. And I get 8. My height is 8. And we're dealing with centimeters. And that's it for 1.4 part 2 isolating variables.